AES, Advanced Encryption Standard, one of the most trusted encryption algorithm in the world, is a symmetric key algorithm. Means same key is used for encrypting the original message and same key is used to get the original message from a cipher text. It is standardized in 2001 by the NIST and is being used from military secure communications to your WhatsApp secure messaging. And AES supports the three key sizes: AES 128, AES 192-bit, and AES 256-bit. Here 128, 192, and 256 are the bit size of a key, cryptographic symmetric key that will be used for encryption and decryption of our messages. For most of the practical applications of IoT nodes or the consumer electronics, AES 128 is used as it is fast and it provides security. But for more security concerns areas of like military equipments or automotive ADAS systems, AES 256 is used as where performance is not an issue, but the security is very highly important. Now let's talk about how data is encrypted using symmetric ciphers. So within symmetric ciphers, there are two categories: stream ciphers and the block ciphers. In the case of stream ciphers, the data is encrypted bit by bit. Means the original message which is input for an encryption or decryption, a single bit by bit gets simultaneously encrypted or decrypted. But in the case of block ciphers, the encryption or decryption happens on the fixed block size of an own input message. That is, it can be the fixed block size of either 128 bits, that is 16 bytes of an original message will be first of all gathered, or will be first of all this collected, and then the encryption or decryption will be happening. Same way 128 bit, 256 bit stands for 32 bytes. So getting 32 bytes of an original message at first, and then encryption decryption will be happening on it. And AES is a block cipher, that is, it performs the encryption decryption on a 128-bit original message in a fixed block size. Now here is a simplified version of how AES algorithm blocks symmetric algorithm works. So we take an input message, that is the data that we want to protect, and then we have a symmetric key, that is the random string of bytes that can be of either 128 bits, that is 16 bytes, 192 bits, or the 256 bits, that is of 32 bytes. Now what this AES algorithm does is it performs mathematical transformations on this input message on a multiple rounds. If we have taken 128 bit, then 10 multiple rounds will be performed. In the case of 192, it will be 12 multiple rounds, and 256 bits would be having 14 multiple rounds. And what does each of these rounds have? These rounds involve steps like of sub bytes, that is substitution of data, shift arrows, rearranging the input data, mix columns, mixing data across the columns, and add round key step in which combining this data with the key. Each round makes the data more scrambled and secure. And to decrypt the data, we simply reverse the process using the same key. Now, as stated, AES is a block cipher. That is, it will only encrypt or decrypt at a time of fixed block size, the input data of a fixed block size of 128 bit, that is 16 bytes. But in real life, it can be that we will be having much more data, like of in the case of file handling or logging, we can have much more data from 16 bytes, or we can have very small data to encrypt or decrypt the sensor data of 2 or 4 bytes. In that case, the AES 128 will alone not work, and that's why here comes the concept of AES modes of operation. AES has different modes onto which we can make the AES algorithm work to make it use for different block sizes and make the AES use in a stream cipher. From real-time ECU secure communication to the encrypted flash storage, these AES modes are used for securely encrypt or decrypt the communication between two embedded devices. And these modes are AES CBC, AES CTR, AES CFB, AES GCM, AES XTS, and AES OFB. And these are AES modes make our secure communication works. Now, further in this video, we are going to understand different applications and use cases of these AES modes with respect of real-time automotive ECUs example. We will dwell into exact use case and application, which AES mode to be used in which kind of secure communication, and why why not other type of AES modes can be used on those use cases.